Lesson 6.4 is about combined transformations. In this lesson, we're going to transform figures using a combination of transformations, and we're going to identify a combination of transformations as well. So first, you need to know the rules. So we're going to review those quickly. The first one is a dilation. In a dilation, you take x, y, and you multiply them each by the scale factor. So in this case, the scale factor is 5. So we have 5 times x, and then 5 times y. The next rule is a translation, right 2 units and down 7. Remember, left and right always change the x. Right is going positive, so we add 2. Up and down change the y. Y is going down, so we subtract 7. The next rule is a reflection. If we reflect across the x-axis, then the x stays the same and the y value changes to the opposite, which makes sense because when we flip across the x-axis, it flips upside down, so the y changes its sign. Reflection across the y-axis is where y stays the same, but x changes its sign. Then we have a 180-degree rotation, which is actually a combination of both the reflection across the x and y-axis. This is where x and y change their signs. Then we have a 90-degree clockwise rotation. Remember, if it's 90 degrees, that you have y and then x. But if it's clockwise, then we're dealing with the original x changing its sign. If it's 90 degrees counterclockwise, then it's still y and then x, but this time the original y changes its sign. So we're going to just kind of note some different facts that will be helpful for us in combining transformations. This lesson's about knowing the rules and looking for patterns to use multiple transformations. If a figure changes its size, what type of transformation must be used? That would be a dilation. If the figure is upside down and backwards, what one transformation could be used? That is a 180-degree rotation. It's the same as reflecting across the x-axis and the y-axis. Number 3, when only looking at the ordered pairs, a transformation that just changes the signs could include a reflection or a rotation. It could be a 180-degree rotation if the signs are all that change. If the coordinates swap and some signs change, then we're probably looking at a 90-degree rotation. Remember, blank figures have the same size and shape. Congruent figures have the same size and shape, but change position. Blank figures have the same shape, but not the same size. Those are called similar figures. The shape is the same, but they're different sizes. That would be the result of a dilation. So we're going to do some problems together. We're going to use this diagram for exercises 1 and 2. It says, number 1, describe a sequence of translations, reflections, or rotations that would transform figure E into figure F. So it appears that it's turned on its side. So we know that there is some type of 90-degree rotation. And I'm noticing that it went one quadrant over and it went clockwise. So it's a 90-degree rotation clockwise. So I'm going to go ahead and note that as one of my transformations. It's not all, but it is one. And if I do that, I can note that it will end up right here. So this is the rectangle E after it's went 90 degrees clockwise. And then we could think what else might have happened. It appears that it's just slid over. I can see that it slides 2 units to the right. So it appears that there is a translation. Two units right. Now, are figures F and E congruent or similar? Well, they are the same size and shape, so they are congruent. An explanation, they are the same size and shape. If they were similar, they'd be the same shape, but the size would change. Number 3, describe a sequence of translations, reflections, or rotations that would transform figure G into figure H. Well, it's just looking for translations, reflections, and rotations. And this figure got smaller. So that means there had to be a dilation, at least a dilation. So that's not possible. It's not possible using only translations, reflections, or rotations. So are they congruent or similar? Well, I can tell that figure G has lengths that are 4 and 4, and H has lengths that are 2 and 2. So it is similar. Figure H has lengths that are half the size. So they're similar. Figure H is the same shape but smaller. Number 5, describe a sequence of translations, reflections, or rotations that would transform figure J into figure K. Well, I don't have vertices labeled, so I can't really tell if these are backwards of each other, but they're definitely upside down. This bottom part of figure J matches the top of figure K. The top of figure J matches the bottom of figure K, and they're both 2 units tall. So they are congruent, and it appears that maybe this is a 180-degree rotation because it went 2 quadrants across. So let's just see. If I were to rotate that 180 degrees, then I would take this point and it would match to this point. This point would match to this point. This point would match to this point. And this point would match to this point. So that is the result of a 180-degree rotation. And that's not even a sequence of transformations. That's just one transformation. So I could do that, or I could get a sequence. Maybe there was a reflection. So let's just flip that across. So I've got a reflection across the x-axis. I misspelled that. And a slide or translation that goes right. We'll start from here. 1, 2, 3, 4, 5, 6, 7 units. So that would be an option as well. And there's actually other combinations of transformations you could use to go from figure J to figure K. Are they congruent or similar? They are congruent, and an explanation is they are the same size and shape. Let's look at the next page. We're identifying each transformation from the original to the image, or we can also call that the pre-image to the image, and telling if the figures are congruent or if they're similar. So I'm going to start by looking at my x's. From A to A prime, I go from 0 to 0. From B to B prime, 3 to negative 3. From C to C prime, 7 to negative 7. And from D to D prime, 4 to negative 4. So I can tell an obvious pattern here going from x, y, of what happens to x, it changes its sign every time the sign changes. And then let's look at the y values. So from 2 to negative 2, 4 to negative 4, negative 2 to positive 2, negative 4 to positive 4. Every time the y value also changed its sign. So we've written our rule. This is a 180-degree rotation, and it is congruent because a rotation just changes the position, not the size of a shape. Number 2, let's see what's happening to the x's first. It goes from negative 3 to 2, negative 1 to 4, 1 to 6, 0 to 5, negative 2 to 3. Now I could look for several different possibilities of what's making these numbers change. I could look to see if maybe it's being multiplied by a scale factor, but looking at these numbers, they're not consistently multiplied by the same number. I could also look to see if x and y are swapping places, but that is also not happening. So the only other option that must occur is that there is a translation. So there's a slide, which means that it's adding or subtracting the same number. So from x, y to x, we are seeing that x is changing by either adding or subtracting the same amount. It looks like it's adding 5 every time. Let's see what's happening for y. So for y, we go from negative 4 to negative 5, negative 2 to negative 3, negative 4 to negative 5, negative 7 to negative 8, negative 7 to negative 8. Once again, this has to be a translation already because the x was translated. So what we see is it's either adding or subtracting the same number every time, and the y is getting smaller, so it's subtracting 1 every time. So we describe this as a translation 5 units right, 1 unit down. And a translation is congruent. It doesn't change the size of the figures. Okay, your turn. Try number 3 and try number 4. Give yourself a little time. You can pause this video and then come back and check your answers. Okay, so now you've worked these and you're here to check your answers. Number 3, each coordinate multiplied by 3. So there was a dilation by a factor of 3, and since the figure increased in size, it was similar but not congruent. Number 4, each coordinate, the x stayed the same, but the y changed signs. So it was a reflection across the x-axis, which meant that the figures were still congruent.